inversion alert system in the United States also. And so I thank the commissioner and many others of you for helping that moving on forward. I am Daryl Ritchison. I'm the director of NDAWN, the North Dakota Agricultural Weather Network. And I'm actually going to start this morning and give a brief overview of NDAWN, some of the things that we're doing. I'm then going to move on to look back a little bit into 2020 as well as 2019 to some degree, all background materials to move forward and give you why I think certain things are going to be occurring during the 2021 growing season. So let's get started. This, if you go to the NDAWN homepage, is what the opening page looks like. And on that NDAWN homepage, there's 131 stations. Those 131 stations have access to all of our crop guidance tools that are available, as well as a lot of historical tools. Over the course of the last 3 or 4 years, NDAWN has expanded greatly. When I started at NDAWN back in 2014, we had 73 stations. And now we are up to 161 stations. So we've more than doubled in the past almost 7 years that I've been with NDAWN. My weakest link in NDAWN, I'll be honest, is IT support. I only have one programmer. I am very fortunate that I have a very talented programmer, but one person can only do so much. So right now, although I have 161 stations, only 131 are totally available on our homepage. So to make up for that, those additional 30 stations in turn have another place to actually get located on. But I do want to briefly let you know that some of the stations that we've added that are not on our homepage would include a station that we installed up in Wales, where it actually rained this morning. It's not too many times I can say it's rained in Wales this time of year, but that was a station that we worked with in cooperative agreement with many growers in that area. We've worked with the Devils Lake Basin Board, Water Board, to put up a station in Clyde, Perth, as well as Wolford. We did move our Can-Do site slightly this summer for a little bit better data. We have another station down here in Ayers. We have a station we installed in Glendon, down in Wolverton. And then out here in western North Dakota, you'll notice there's a big clumping of weather stations. We've added over 30 stations there just since last June. Those 30 stations are part of the Western Dakota Energy Association Wise Roads project. So really what we're trying to do out there is put NDAWN stations in place that in turn can be used to monitor the roads, the precipitation amounts, which will help the oil industry greatly. But at the same time, it turns Western North Dakota into one of the best places in the world for weather data, because now we have those additional stations. We don't have them all online yet. We're hoping to get all those stations online before the 2021 growing season, but all our crop guidance tools, say our fusarium head blight guidance for all the wheat growers in that area, those tools will be available. So Western North Dakota historically has really been a weather void, very little good data out there. We've transformed that into one of the best places in the world for weather data. Plus, of course, the new installation of the new radar system up in Williston really gives that area a big benefit. But please be patient with us, and we're going to try to get those stations online before the next upcoming growing season out in Western North Dakota. So we really appreciate our partners. In the short term, if you're nearby one of these stations, you can go to this link, cloud.ndawn.org. And because this is virtual, probably half of you will stop listening to me and type in that URL into your phone or wherever you're watching from right now. Oh, please hold off for an hour. But in any case, if you type that in, this is the page that will pop up, and this will link you to all 161 stations, and really technically 162 stations, because we have just one precipitation station out there as well. You'll also notice we have photos now across the state that are broadcasting live during the course of the day. And one of the things I did want to point out, because of what Commissioner Goring said, and almost all of you know how dry it's been, we now have nearly 50 NDAWN stations with soil data. And so if you click on any of those links in here, this is all soil, all these stations, you will get some soil data for a lot of parts of the state of North Dakota. And we were going to be expanding that because you may have read in the paper, NDAWN recently got a $6.4 million grant from the Army Corps of Engineers. That $6.4 million will be used to upgrade all of the NDAWN stations in the upper Missouri River Basin, as well as adding additional stations. Right now, I only have the Mandan station, otherwise Morton and Burleigh County. only has that one station. That will be improving in the next few years. And a lot of the stations, even with the Western Dakota Energy Association and other projects, will be updated with more soil moisture probes as well as winter precipitation. The Army Corps is going to be using this to monitor what the flow level is going to be into the Missouri River. So say we don't have a repeat of what happened in 2011, but at the same time, those stations in turn benefit the citizens of North Dakota and especially agriculture in the state. So that will add additional stations as we move forward through time. This is just an example of what the cloud service looks like. I chose our station in Wales mainly because this is the rain that fell last night. You'll notice it will tell you if there's an inversion present or not. There's a lot of additional data on here. I will say you can scroll through like this and go back since the beginning when this station was installed. It gives the hourly weather data that I associated with. All of these graphs have a little calendar icon in the corner, and in turn you can go back and look at data specifically. Yes, you can do this on our NDAWN webpage for those sites, but those sites that are on our NDAWN webpage right now also have this service available because there will be more specific information available on this website than what we offer. This is a little bit bigger view, and you notice this is our Perth camera, our station up, this is just to the east of Perth, about 7 miles. Think of it also, it's about equidistance between Perth and Rock Lake. That site has a camera, a lot of our tower sites do, and during the daytime, you can monitor what the cloud conditions are and such. This is also one of our newer stations in Clyde that has a camera. You notice someone was probably burning off some activity yesterday, maybe some more, I don't know what they were burning for sure. I probably shouldn't speculate. But in any case, it made for an interesting scene as the sun was setting back behind the clouds yesterday afternoon. But I mentioned Clyde because if you look carefully, we installed this station pretty much in the middle of a wheat field. Very appropriate for my audience today, for many of you at least. And this is Perth soil moisture data. You will notice that moisture data is measured in this concept called volumetric water content. And really what it is what percentage in a way is water in the soil. Well, you know the soil is there. So say that's 50%. There's air in the soil. So that's a part of that equation, as well as the moisture. In this case, this is the way, Clyde 2-inch sensor. So just near the surface, you notice how the moisture content gradually declined. And then you'll notice this big giant spike. Well, that big giant spike is not real. What happened during these spikes here, and especially this permanent spike, the topsoil froze. And then again, there's no water in the soil. There's ice in the soil at that level. So the sensor can't measure it. So when you look at the soil data, do keep that in mind. But for instance, Perth, soil moisture wise until freeze up was in pretty good shape. But Clyde was in pretty good shape. But again, that's not necessarily the general rule across the state. Now, Logan Center, which is a site we put up in 2019 rather, that station is off in the western part of Grand Forks County in Logan Center Township. That site has not frozen up yet. So in turn, I was able to show you this map. So areas where are not frozen up, or when you use this next summer, I have a soil physicist that works for me, fortunately. And so we have been doing some estimates because volumetric water content can get a little bit confusing at times. So what we did is try to give an estimate to soil saturation. And this is 2-inch, and notice, it's 2.4%. And I was just at Logan Center installing some equipment about 4 weeks ago. And in turn, yeah, it's just absolutely bone dry. But this represents much of North Dakota pretty well. The top 4 to 8 inches, very dry, but because of that wetness, that it really, in many ways, extreme wetness we had in the fall of 2019, just a year ago, there's still a lot of subsoil moisture. I still have a lot of probes that are saturated in water down at 40 inches, our lowest sensor that we have in there. But in any case, this will give you an estimate for all of those sites that we have. But you noticed on there, it did say in the top, soil moisture data is not valid when temperatures are below freezing. So do keep that in mind if you're going to take a look at some of that data, because this is probably new information for many of you listening today. So I wanted to very quickly just review 2020. And I did not have an opportunity to speak at this conference last year because I had a conflict on that day. But if I was with you last year, and if you did hear me speak last year in any other location, my general thought for 2020 was for a dry summer. And oddly, I used not really a forecasting tool, but one of the approaches I used last year was this graphic. Now, this is Fargo going back to 1881. And you'll notice something very interesting about this. And this is just living in the Northern Plains. And I'm just using Fargo as an example. The reality is I could use pretty much any long-term site in North Dakota. Notice the spikes in rain. What happens the next year? Spike, what happens the next year? Spike, what happens the next year? Spike, what happens the next year? 2019 spike, what happened the next year? Yeah, parts of the Red River Valley had a pretty wet period in July and early August, but a vast majority of the year has been dry. In fact, Fargo to this point is well below average for this year. So again, it really wasn't a forecast tool. It's looking back at history. We've never really had two exceptionally wet years in a row in the past 140 years. The only exception was back in Bismarck. Bismarck has the oldest temperature and precipitation records in the state. When that station first started in the fall of 1874, 1875, and 1876 were two very wet years, and the two wettest years on record until 2019, when that 2019 took over second place. But still, those first two full years of records in Bismarck were in turn two of the three now wettest years since. So it is a testament of the longer the record you have, the better understanding you have of the climate in North Dakota. Now, as I've already hinted to, I had suggested, and it wasn't at this talk last year, but my winter talks last year, that 2020 probably going to be a dry year in most areas. And I always say that because it's rarely dry for everybody. There's a couple of years where we can say that, but most years there's some pockets where it's wet. And back in June of this past year, now this is Bismarck's precipitation for the year, and I want you to notice something. The lowest, 2020, if your computer screen is good enough resolution. So on June 26th of this year, Bismarck was the driest year on record to that point, surpassing 1936 and 1934. Well, really in Fargo, it wasn't exactly the same, but it was one of the driest years on record in Fargo at that time. It was one of the driest years to that point on record in Grand Forks. It was one of the driest years on record to that point in Williston. So back in June, the people who had heard my talk go, wow, Daryl, you're looking really good for your forecast for this year. And I said, true, but I will say the next several weeks look like we're going to get moisture. And so hopefully we'll get enough moisture to get us through this upcoming growing season, which some of you did, and many others just never really did through the course of the entire year. So now this is Fargo through June 30th. This brown line is the average. Notice Fargo will very likely, unless we get a 30-inch snowstorm, which is never say never in this climate, through the rest of this month. So Fargo is a drier than average year to this point. And here's Bismarck. Bismarck right now, and this will likely stay the same, but Bismarck to this point, right through there, is at its third driest year on record. So the third driest year since 1875 when we have full records. So yes, it's been an exceptionally dry year in some parts of North Dakota. This is Williston. Williston is the same thing. Williston right now is having its fourth driest year on record, and looking for the rest of this year, it's probably going to stay as the fourth driest. So again, when you think fourth driest, it's drier than 2012, 2006. It's drier than 1936, 1934, 1988, all these, some of these years that's in everyone's mind as these exceptionally dry years. This past year was just as dry. One of the things that ended up saving us in many ways was the wet fall in 2019. In fact, in October of 2019, so a little bit more than about 14 months ago, I spoke at the State Water Conference in Bismarck. There's a lot of ranchers in that conference, and they asked me about the wetness. And I, at that point, had already said, you know, I think in the end, I know you're suffering right now, but this rain that you got and the wetness that we're currently experiencing this fall is probably going to be a good benefit, because I really think I personally would be much more concerned about being too dry, not too wet in the near future. And that in turn, unfortunately, you know, it did happen. You know, when I make some of these forecasts, trust me, I make the forecast, doesn't necessarily mean I want it to occur. Now, this is Grand Forks, and you notice Grand Forks also at the end of June was one of the driest places on record to that point. But look what happened in the summer was this huge surge of rain in the northern Red River Valley. But notice for the last really 3 or 4 months, pretty much flatlined. Most of the state has gotten very little moisture over the course of the last several months. So here was growing season precipitation. The numbers on this graphic are associated with normal precipitation. So really most of the yellow areas, you're below average for the growing season. And by growing season, usually traditionally May 1st through June 30th, I'm sorry, September 30th is used. And of course, some years we don't get all of that. This past year was definitely one of those years. But this is that traditional 5-month growing season, approximately when we're planting and harvesting. And you'll see much of the state drier than average. In many places, look at Bismarck, less than half of normal. Same thing out in Williston. Matter of fact, these areas that were closer to normal in western North Dakota, that's all because of one day back in July when it rained 3 to 5 inches of rain. And that was pretty much the only rain some areas got of consequence the entire season. You notice southeastern North Dakota, pretty close to normal. And you folks up in Kitsap County, you had a monsoon. You had that huge rain at the end of June. It was pretty much localized to Kitsap County, but then you had a couple of other ones during the course of the summer as well. But then if we take the actual just summer, and by summer, June 1st through August 31st, you will notice the wetness we had. And much of this wetness, again, there's a couple of exceptions in everything that I say, but much of the wetness came in really in about a 4 or 5 week period over the course of the month of July, and just a little bit into June and a little bit into August. But even during the summer, you'll notice there was pockets of exceptional dry weather that was out and about throughout the region. So things really turned very, very quickly, of course. Now, this is temperature-wise. As everyone knows, listening pretty much, we had an early freeze this year. Not only an early frost, we had an early freeze this year. The positive of that, if there is any, there's really never a positive in an early freeze, but at least we had a warm summer. And in turn, this is the entire growing season again from May into September. You notice early May, many of you couldn't plant because it was too cold. Then we had that early frost in most areas that hit on September 8th or 9th. But the whole growing season mostly was a degree or two above average. But if we take just that core of summer again, last summer in 2020 was one of the warmest summers on record. And again, by summer in climatological and meteorological circles, June 1st through August 31st. And you notice we're 2-3 degrees above average. So we had much, much more growing degree days this past year than we did, say, in 2019. In fact, many parts of the state of North Dakota had anywhere from 100 to 300 more growing degree days, base 50, which would be used for corn and soybeans, than we had in 2019. And then if we use base 32 for wheat, then that number climbs even much, much higher than that. So we did have, and at least in the Red River Valley, the moisture and the rain, we had pretty good yields. But in western North Dakota, of course, most areas never really received that rain to benefit with those extra growing degree days. Now, this is the NOAA, or the National Centers of Environmental Information's map. And this is their May through September analysis from this past summer. I use this for a couple of reasons. Number one, these are the types of graphics I will use to show you what I think is coming in 2020 through all these climate divisions. So North Dakota has 9 climate divisions. Minnesota, I do believe, has 9 climate divisions as well. But I mention this as I don't think there's going to be any argument from anyone that last summer was a warm summer. This map shows that. Most areas say we're approximately 1 to 1.5 degrees above average. It doesn't sound like much, but that's a lot of extra growing degree days. And then this is precipitation. And you notice, again, no one in western North Dakota is going to be surprised by this graphic. It was a dry summer. But some of you folks up in northeastern North Dakota, northwestern Minnesota, are probably sitting wherever you're watching this from, maybe your home office, and going, huh? A normal summer? Are you kidding me? It was really, really wet. Well, number one, they don't use NDAWN data, and they don't use your rain gauge either. I have a lot of arguments with this graphic a lot of times, and this is one of those examples going forward, but this is how it will go down into the record books. So I talked a little bit about NDAWN. I talked a little bit about 2020, and now I really would like to talk about 2021 and beyond. I had a conversation with someone, I think it was about 4 or 5 weeks ago. I think it was back around Halloween or thereabouts. And someone had asked me, Daryl, I've heard you speak many times. Do you still think 2020 is going to be the end of the wet cycle that we're in and going into more of a drier pattern? And I said, yes, I still do. And I told that person, I'm kind of surprised that you actually remember that. Really, my whole concept of the 2020s being the end of our wet cycle that we've been in many ways since 1993 comes back down to 2006. And many of you may remember 2006 was a very dry summer. Many areas had the warmest temperatures that they had experienced in over a decade to that point. And I remember I was back in my television days at WDAY, WDAZ, and a lot of people would ask me, so Daryl, this is the wet cycle's ended. And I go, I really don't think so. We've only been in this wet cycle for about 10 years. And historically, they tend to last anywhere from about 15 to 30 years, with the average being more so in that 20 to 25 year range. So in turn, I just think this is an anomaly, because when we have dry periods, there's always a wet year thrown in there. When you have wet cycles, you always throw in a few drier years in there. So I said, I really don't anticipate that change until 2020. And then that started the whole concept that a lot of you may remember. This is Bur Oak Chronologies, and Bur Oak's a natural species in North Dakota, grew along the river bottoms when Joseph Nicolet explored North Dakota. And of course, Nicolet of fame in Minnesota, Nicolet Mall, for instance, there's a county in Minnesota named after Nicolet. Joseph Nicolet actually spent a night about a half a mile from the house I grew up in Minnesota, actually, in one of his trips in his diaries. But when he was exploring North Dakota in the summer of 1839, he just made a little comment in his diary. He was following the Cheyenne River up towards Devil's Lake, which was his ultimate goal of his trip. And he had mentioned, I would never even know that there was the Cheyenne River Valley, and he called it that, and even in 1839, off to my east, because all the trees are too short and they're down in the valley. And of course, we really were, for the most part, a treeless prairie at that point. But Bur Oak was one of those species. And of course, pretend you're a tree. And if you're a tree, you're in slumber right now. It's winter. We can think of it as hibernation as a way. And if you're a plant pathologist or someone, you'd probably just laugh at the way I described that. But they're just in a dormant stage. And then what happens in March? Well, March is the equinox. We get a lot of sunshine. We have a lot of potential for warmth. The snow starts to melt. And as a tree, you start to awaken. Well, what happens if you're a river bottom tree in North Dakota most Aprils? Well, you might not necessarily have a catastrophic flood, but the river comes out of its banks. And if you're 20 yards from the river, your roots get covered in water. So in turn, what happens? Well, you have to sit and wait for that to really go away, get the oxygen back in the root system for you to continue awakening and get your leaves out. Well, most trees just come and go. Bur Oak leaves a little bit of a scar when that happens. You can index that, and in turn, you can kind of equate what years were wet and what years were dry. So I'm going to take you back with the Bur Oak chronologies, and this is the index that takes us back really into the 1700s. So it gives us about a 300-year perspective. And some of these chronologies were done through NDSU, really in many ways using log cabins that were originally built when the Europeans settled this area. What did they build their log cabins out where they're near the river? The Bur Oak, very hardy tree, very good to build your house from, and because most of these trees, of course, have long since been gone. Well, here's the chronologies, and here's three very well-known dry periods. Of course, the 1930s, which most of you are familiar with, but also the 1860s. There are some indications that the Northern Plains may have been just as dry as the 1930s. The big difference is the natural prairie was here. Prairie species were used to these droughts. Of course, in the 1930s, we had plowed that all up. We had all that exposed soil. And so things didn't fare quite as well when it was exceptionally dry in the 1930s. But you notice when Joseph Nicolet was here was the beginning of really of another dry period. But there were also, of course, some wet periods moving forward as well. So the 1870s and 1820s. In fact, last autumn, 2019, of course, was the wettest autumn on record in North Dakota. The one exception was the southern Red River Valley. Say Fargo southward, it wasn't the wettest autumn on record, but most of the state it was. And of course, it was not only the wettest autumn on record across much of the state, especially across the northern half of the state, it was way beyond the wettest year on record. So is that unusual? What happened there? Of course, climate change was brought up with all of that. And I go, well, the reality is it's probably the wettest autumn on record since 1825. And no, we didn't have 500 rain gauges in the area in 1825. But there's a lot of evidence to suggest 1826 is the flood of record in Winnipeg, for instance, which was Fort Garry at that point in time. So I always remind people there are some weather events that only happen once out of every 200, 300, 400 years. Is that unusual? I mean, that's, your perspective. I say something that occurred 3 times in the last century. Yeah, it's unusual, but it's not unprecedented. And that's always a difference in that, because our record period is reasonably short. But again, it's a wet and dry period. But if you go through and do this analysis and you do some other analysis, is techniques and tools, and there's many more tools than Bur Oak to come up with that average of, say, 20, 25 years for our average wet cycle. Now, this is the Great Lakes water levels for all 5 of the Great Lakes since 1918. You will notice, if you look carefully, that there was a peak in all of the lakes in the late 1920s. What followed that? Correct, a drought. There was another peak of the Great Lakes in the early 1950s. What followed that? Correct, a drought in the late 1950s. There was another peak in the Great Lakes in the early 1980s. What followed that? Correct, a drought. We have now reached another peak in the Great Lakes in the years 2018 and 2019. Using history as a guide, what do you think is going to follow us into the 2020s? No one knows the future. I look at patterns. So this is just yet another tool to me indicating that we may transition back to a drier period. And by drier, it's not 10 straight years of drought, because even in the 1930s, it wasn't 10 straight years of drought. But really what I always tell people is we're going to go back to that historical rainfall average. Most of North Dakota has averaged somewhere between 15 and 25% more rainfall during this wet cycle than we did from, the 20th century average. And so that's the tools and thought process that I have going forward is, yeah, we're just going to go back 10, 20% on moisture. So instead of, say, getting 20, 21 inches of rain, you might get 17, 18, but it changes crop rotations. It exchanges probably the amount of evaporation, because it's going to be a little bit more sunny if we get a little bit more rain. There's all these little subtle factors that will go in play going forward. So really, in many ways, depending on your age, once the wet cycle ends, we'll probably go back to either what your father or grandfather farmed for decades with that type of rainfall. Still natural variations. Some years will be wetter and drier than average, but the overall average. So one of the tools, if you ever heard any of my talks about looking at future weather, deals with sea surface temperature anomalies. Because where's all the heat capacity of the planet? Not in the atmosphere, it's in the oceans. Matter of fact, it's not 100%, because the atmosphere does have heat capacity, but it's well over 99% of the heat capacity of the planet is really situated within the oceans, not into the atmosphere. So I'm going to just move this forward and animate it. And I want you to watch this area right through here. And you notice it turned pretty blue. I will remind you that these colors are not necessarily temperatures. They're anomalies from average. So the blue areas are colder than average, and the red areas are warmer than average. So up here in the North Pacific, if you would jump off a boat in your Speedo or whatever, you in turn would probably, hypothermia in about 15 or 20 minutes. The water is very cold. It's above average, but it's still very, very cold air. So here's the animation. So there's this cold pool of water in the Pacific Ocean right now. And that in turn would be described as a La Nina, which is the opposite of an El Nino. I oftentimes like to show this graph because this is actual sea surface temperatures. You'll notice this little green area right here. You can actually see there the colder water. Remember all that red you saw in the North Pacific? Can you see it at the actual? Can you see a little plume where it's a little warmer? Not really. It's still bitterly cold, because if you read online, you'll see a talk. A lot of meteorologists will go, well, that warm pool in the North Pacific is altering the jet stream. It's doing all this stuff to our weather, and this is why we're going to get a certain weather event. And I'm going, no. The water is warmer than average because of the jet stream, not because of the opposite. They got their cause and effect all backwards on there. And the other thing I should note is that warm pool in the North Pacific is pretty shallow. So you don't have to go very deep into the ocean, and it's at normal temperatures. Whereas the La Nina, that cold pool in the equatorial Pacific, is actually very deep. And so it's going to stick around quite a bit. One storm or one little event is not really going to alter or change what is going on in that area. So La Nina is an equatorial Pacific of a 0.5 degree Celsius, think of it about 1 degree Fahrenheit, colder than average. And what I didn't put on this screen is for 3-month average. Whereas an El Nino is the equatorial Pacific is a 0.5 degree warmer Celsius, or 1 degree Fahrenheit approximately, than average. Again, averaged over a 3-month period. Why does this matter? The world is, the Earth, the planet is round. Where is most of the surface area on the planet? Near the equator. The Pacific Ocean is 38% of the planet. What that happens in the Pacific Ocean has an effect. Really, it kind of cascades through the entire global system. North America gets influenced much more than Europe, but in many ways, everyone around the world has some impacts when this happens. Just to give you a couple of examples of this is what the La Nina looked like back in 2016, 2017 timeframe into early 18. So the graphic's actually in early 2018. And then the El Nino is the famed one back in 1982, 1983. But I wanted to show you these graphics because look at the rest of the world. What are the sea surface temperatures elsewhere? Because here's the thing, and I've talked about this, I think, even at this show a couple of years ago when I was there and many of my other talks. Oftentimes, La Ninas go, well, there's a La Nina, so there's going to be a drought. And I always remind people in the weather, X never equals Y. Because the reality is it might be TUVWX equals Y. There's always something else going on. It's just one thing causing another thing is way oversimplistic. And when you hear someone say that, you should instantly think, well, this guy doesn't clearly understand what he's talking about, or that's just not true because it's not that simplistic when you do things. So I always want to point that out as a reminder to people that just because there's a La Nina, 1988, there was a La Nina, there was a drought. And from that point forward now for 30 years, people have thought that. I can show you La Ninas when there wasn't a drought. I can show you La Ninas when there were. When there's a La Nina and a drought, it might be a little bit more likely, but it's not the only cause of that going forward. The other thing is there's Nino zones. So where is the coldest water? Where is the warmest water in this? Because if the really cold water is here, we might get a different impact than if the really cold water is here. The whole area might be colder than average, but where is the core? So those are additional tools that you have to look into when you're going forward. So this is model projections of our current La Nina. Here's the 0 line. So anything down here would be a La Nina, and everything up here will be an El Nino. And of course, notice we're down. We have a La Nina. What's going to happen? Here is June, July, and August. This line forward. Notice most computer guidance at that point no longer have us in a La Nina. Now would be the core of the growing season. The thing is, there's usually a delay. So the atmosphere might think there's a La Nina even when they're going forward. But again, this is just one of many tools and guidance that going forward that we use. So here is the Oceanic Nino Index. So again, anything up, this is all El Ninos up here. And up down here is all La Ninas. And you notice right now we're in a moderate La Nina. This is the strongest La Nina since back in that 10, 11, 12 era. What happened during that time frame? 9, 10, 11, quite wet. Some areas started to dry off in 11, and then we got hit, boom, by a pretty significant drought in the year 2012, for instance, which was another year where people thought the wet cycle was going to end, which it did not. So what I do, one of the many techniques I use is I look at where we're at, look in the past when we saw similar conditions, then in turn, those similar conditions, what was the kind of weather we had? Outside of what happened in 2019 in the fall, a lot of our weather lately has been following these past years here, reasonably well. So again, it's a clue because really what I'm trying to do when I'm forecasting long range is piece a bunch of the puzzles together and see how they fit. My track record has been pretty good in the last 5 or 6 years, never perfect for all areas. And I'll be honest, I'm due for a big giant bust at some point for these long range forecasts. It's just the nature of the beast, working and trying to think what patterns are going to be 6 or 12 months in advance. Now, this is global sea surface temperature anomalies again, and I use 2016 and 2020 because in 2016, Western North Dakota was dry. Eastern North Dakota some areas were exceptionally wet, which was also the case this year for a while. Notice how this year, so if you're going to say, if I already had a lot of people talk to me, go, so we're going to just repeat 2017, correct, Daryl? I go, not necessarily, because the whole world is not quite set up exactly the same way. But there are at least some clues and hints going forward that we might be dealing with additional dry year going forward, but not necessarily the same. So I had mentioned these other tools, and these are all acronyms like the PDOs, the Pacific Decadal Oscillation. I'm sure some of you have heard me give a talk on that. The AMOs, the Atlantic Multi-Decadal Oscillation. The key here is notice all of these but one end with the letter O. And what does O stand for in every single one of these techniques and tools? They're oscillation patterns. Some of them last 20 years, 30 years. Some of them last 6 to 8 weeks. Matter of fact, we're in an oscillation pattern right now. Why the last 6 weeks have generally been bone dry and for the most part, very, very warm for the time of year. But this is about to change as one of the oscillation indexes changing going forward, I think, for the rest of the month. So if you've heard a talk from me before, I always use this graphic. No, it is not my car. I wished it was, but it is not that cool, as I always tell people. But this is my pretend DeLorean to go forward in time. And this is what I think is going to happen in 2021. So my temperature analogs, looking at the past, looking at a lot of data. I spend many hours looking at this stuff because I enjoy doing it, actually. I don't have much of a life, as some of you know. But my temperature analog package really suggests the northern plains, much of it in 2021, especially during the summer months, say the middle of May through the middle of September, the core of the growing season to be above average, but not as warm as 2021. So we'll probably back off, if everything goes according to plan, some growing degree day units. So I'm leaning more towards closer to average or a little bit above. A year ago, I was very confident that 2020 was going to be warmer than average, even more so than my precipitation forecast was, and in turn it did. So again, you have to look down here at the chart. This is barely above average. Really what this is showing is a near average growing season for next year. Now I'm going to show you two analog packages for precipitation that may confuse you, but I can foresee two scenarios. And you know, this is a big difference down here, but the two scenarios are not that much different for us. You notice this scenario, North Dakota generally average or drier than average in 2021. And in this scenario, the Southern Plains are a little bit above average, but again, we're dry. So both scenarios in here are a little bit drier than average. So if this comes true, then it would in a way be a repeat of 2016 and 2017 for Western North Dakota, when you had two really dry summers in a row, whereas Eastern North Dakota, you know, kind of, again, 16 wasn't dry except for in a few spots in the east. It was generally wet moving on forward. So I don't know if I necessarily would call this a forecast. It's my analog package and what I think going forward. But I think there's many reasons to believe 2021 being dry, then in turn it really being wet next year, and we have a complete reversal going forward. But this graphics on here are reminders, because this graphic is the core of the summer, June, July, and August of 2012, which was exceptionally dry in the Red River Valley, mostly speaking. But you noticed there are pockets in here that were not dry. 2017, this area right here had the severest drought indices, which made me roll my eyes all summer, but were for the most part really right at the average. Where the areas that were exceptionally dry, the far west, weren't in the lowest drought indices, which again, made me roll my eyes, but that's a different story for another day. But I always want to remind folks that it's rare that everybody is dry or wet. This past summer was my forecast for this year, mostly dry, good or bad? I would say it's good. You folks in Kitsap County just think I would be crazy for saying that because you're exceptionally wet. And that's always the case when you live where we live, because we're highly dependent on thunderstorms. And you know, we all have seen it. That side of the road, wow, they got an inch of rain over here, and this field over here got nothing. It's just the nature of thunderstorms and why making the precipitation forecast in particular, you can get the general flavor, as I like to call it correctly, but you never get everybody right, or very, very rarely, because of those problems associated with thunderstorms and the amount of precipitation that falls from spot to spot. So really, to sum all of this up then, there's reasons to think more dry than wet for next year, which would be devastating if true in western North Dakota. Of course, it would be a matter of how much drier than average. If we're 10, 15%, probably would be doable. If it's another year at 50%, then we're talking, of a realistically strong drought will be present. A lot of you are going to ask me about April. Historically, if you look back at La Niñas, March and April in particular tend to be colder than average. Doesn't mean wetter than average, but colder than average. So even though this winter, most areas probably won't have a significant snowpack, which means, I can get out in the fields earlier. We might be held back by the temperatures more so than the precipitation in March and April. But you have to remember, April could be drier than average for 26 straight days in a row. And then the last 2 days of the month, you get an inch of rain, puts you back up to average, and then delays your planting depending on your soil type for a week. So you always have to keep those things in mind as well. But I think we'll start spring, March and April, drier, colder than average. I think May, like this past year, will turn around and end up being pretty good if my analog set is right. But I think 2021 overall will be a little bit cooler. So I would estimate, for grains, we might get 250 less growing degree days. Corn, soybeans, you might get 100 approximately less growing degree days, just to throw out a number out there. So not necessarily a cold summer, just not quite as warm as 2021. And again, this decadal changes to our long-term precipitation mean. We're getting towards that tail end. I'm still sticking with what I've been saying for 15 years. At least I make predictions, unlike some people that are so far in the future in the year 2060 when everyone will be mostly not with us anymore. But I've been sticking. I really think North Dakota is in the slow process of transitioning out of this wet cycle and moving into a slightly drier pattern going forward. If you want to contact me on social media, that P is Parler. I am still on Twitter. If you follow me on Twitter, I don't use it much anymore. I do most of my social media on Parler. This is my contact information. If you have problems with our cloud service, all of this stuff, please write down that email. I might not get to you immediately, but I in turn very, very much so will get back to you, usually within 24 hours of any questions you might have. And speaking of which, I've saved plenty of time today before the next speaker. If there are any questions, I will answer them to the best of my ability.
Got one here for you, Daryl. What's causing the polar ice caps to melt? Is this normal for the period in time?
The polar ice caps, principally, to be honest, is the Atlantic multi-decadal oscillation. Most of the melting in the Arctic is on the Russian side, north of Greenland, north of Scandinavia, in that area associated with the Atlantic multi-decadal oscillation. A couple of years ago, when the Atlantic multi-decadal oscillation switched briefly into its negative mode, we actually have a great expanse of ice in that area. Once the Atlantic multi-decadal oscillation goes back to its more permanent negative range, which means colder than average temperatures in the North Pacific, I personally have always thought, and again, this is probably a 2020s thing, because that cycle lasts for 20 or 30 years, that we would see an increase in ice coverage over the Arctic Ocean. And then in turn, Antarctica would probably see less. And then everyone can start talking to us how Antarctica doesn't have any ice, because for the most part, Antarctica has been very heavily iced above average for most of the last decade, not every single year. But to me, that's pretty much one of the more principal causes. A sub-cause is really, I think, the growth in Asia of their economies. India, China in particular uses a lot of coal. They don't use the methodologies we do in the United States to clean that in turn. So that increase in soot going into the jet stream and then dropping itself in the Arctic changes the albedo, or the amount of absorption of the sun in the ice. And I think that's had probably a small influence on that.
A few more for you, Daryl, here. How far beyond the local region has the wet cycle of the last 25 years extended into the main corn belt? And secondly, to what extent will the coming dry period extend into the rest of national grain belt?
The question really dealt with the wet cycle. The wet cycle is really, and you can get another opinion on this. This is my opinion, but it's really impacted, I think, all of the northern plains. I'm talking Montana, northeastern sections of Wyoming, north, South Dakota, into Nebraska, Minnesota. In some ways, you could go even into the Great Lakes. I showed you that graphic, over time, how it's been slowly. It takes a lot of years of wetter than average conditions to fill up the Great Lakes. That's a lot of water out there. So it really, I think, maybe the traditional Midwest, Montana to Ohio, Missouri, up through Minnesota, North and South Dakota. So it's been a pretty wide area that's seen above average precipitation recent terms. And I think in time that will gradually transition, not again necessarily to dry, just back to that long-term precipitation norm.
Generic question here. What other regions of the world might have growing problems in the upcoming season?
The growing problems in the upcoming season, there's been a lot of talk about Brazil and Argentina. I did a conference call where I'm standing actually with the Northern Crop Institute dealing with La Nina growing around the world. La Ninas, when they're weak, tend to impact Argentina quite a bit. I remember when Argentina had their problems in their growing season, our winter of 17-18, their summer, that year, I had been asked, I remember telling people if someone's going to have problems this year, it's probably going to be Argentina. And so I've been asked that a lot this year. Interestingly enough, Argentina, no doubt to me, will probably have a drier than average growing season over most of their, say, traditional corn and soybean growing areas in particular. But I've always contended, and there's some data to support what I've been saying so far, is just not quite as dry as they were before. Because, say, Argentina gets more impacted by weak to moderate El Niños, more so than, say, the moderate to stronger ones, which we're in right now. Brazil, in fact, tends to get a little bit more impacts when you go forward with a stronger one. So that's why I think they're having a little bit more impacts again. But I will say what I've already said. One thing does not necessarily equal another. I'm just mentioning it's one of the factors. There are additional factors on there. And going around the rest of the world, Australia, grain growing should be excellent because they tend to get more rain with La Ninas. And there's other factors going on there, warm sea surface temperatures right now that would impact them. Ukraine, I think, will continue to have problems with the current pattern, although they're influenced much more by the Atlantic Ocean than they are with the Pacific, although there's some impacts with the Pacific Ocean there as well.
Okay, got a few more for you here from Greg LaPlante. What about the rest of winter forecasts? Still cold with a lot of snow or not?
If I will tell people what I've been saying since really last July, I always find it interesting. Of course, December 1st was last week. That's the start of winter. So every forecast you hear about winter is from December 1st through February 28th. Or last year, December 1st through February 29th. It was a leap year last winter, of course. And a lot of times people will ask me 6 months in advance. You wait until next May, there's going to be 100 summer forecasts. But here I am in December, 6 months earlier, giving you a summer forecast. The joys of my job sometimes doing it a lot earlier than other individuals. But what I've been saying all summer through the early fall is that this whole concept of La Ninas being cold and snowy is really in many ways a false narrative. Because what that is oftentimes based on is a statistical approach over a whole bunch of years. And there have been 2 or 3 exceptionally snowy winters. And in turn, when you only average 30 or 40, which was most of the state long-term average is, you get a couple 60s in there and you skew the stats. Really, there's more La Ninas that we finish average or below average in precipitation, especially snowfall, than we do above. So I go, the whole concept of this being a snowy winter just doesn't personally make sense to me. But, I will give you the colder for a number of reasons. And I think to me this winter, we're going to get winter in January, February, and March. I don't know if the winter will finish below average because this month, December, is so warm, it's going to be hard to get back. But I've always leaned towards average to a little bit below on temperatures between 0 and -2 to summer through the fall. And then precipitation-wise, I generally have mentioned, I think it's going to be average, and I'd lean towards below in most areas. And so far, at least that part has been coming true.
Okay, I got a few more for you here. What oscillation caused the warm weather the past 6 weeks?
The last 6 weeks, in many ways, there was the Pacific North American. It's not really an oscillation, but it's a pattern. We're really in a northwesterly flow going forward. Matter of fact, we're in a northwesterly flow most of the autumn. Last summer, when people asked me about the fall, I said probably a degree or 2 above average and dry. Nailed to dry. Why didn't I get the temperature forecast right? October 20th through the 30th when we were 30 degrees below average, 20 to 30, and it skewed the whole stats for the autumn. So really, in many ways, the autumn had more above average days than below, depending on your location, or at least equal. But overall, we finished autumn about right at average or a degree or two below because of that 10 to 20 days, the joys of long range forecasting. But that dry pattern, to me, was really associated with the upper level wind flow being more of a northwesterly flow. So it wasn't necessarily one of the oscillation patterns, but it's this pattern called the Pacific North American pattern that gives us a lot of dominant northwesterly flow, which in turn is why weather's been the way that it is. As I always tell people, there's not a lot of moisture up in northwest Canada. So when our flow comes from that direction, there's cold air sometimes, but the reason we've been warmer is the upper level wind flow has been north of North Dakota rather than right over us. So we've been sunnier rather than cloudier this time of year. And then in turn, we've been a little bit warmer, mainly because the extra sunshine and then no snow cover and all the fields being dark right now, even with cover crops, we get a lot of absorption. So we're much, much warmer than that. We just get a 1 or 2 inch snowfall and you will notice really quickly, even that slight snow cover will drop our temperatures quite a bit.
Good. A couple more for you here. Can you please clarify your first bullet on the last slide? Are you saying you expect dry early in the season and then wet later in the season? Or are you suggesting we will be more dry overall in 2021 in comparison to our current wet cycle?
Well, here is that bullet point right there. Reasons to think more dry than wet in 2021. I'm just thinking that from the middle of May to the middle of September in particular, that not everyone, but more areas than that will be below average on precipitation. Does that mean 50% like some of you were last summer? Not necessarily, although I'm sure there will be a spot. 10, 15, 20% is drier than average. And so I'm just really leaning towards most of next drying growing season, especially the core of it being drier than average across most of the area. And again, it's always a degree. You have to remember our current averages are based on 1981 to 2010. That's going to change next year. By the middle of July of 2021, our averages are going to switch to 1990 to 1991 to 2020. And so then all of our averages are going to adjust. And most of you, your averages at Wayne is going to go up. So then in the 2020s, I can forecast below average precipitation for 10 straight years and probably get it right 3 times out of 4, only because that average is skewed. So it also depends on what average you're using. I'm using the 1981 to 2020 cycle. I'm sorry, 1981 to 2010 30 year, which is the current normals, which is a kind of a wet normal. So really next summer, from a historical perspective, the last 100 years of average, we might be right at the average. But our current average, that would be below. And so that, again, is what I'm forecasting.
Okay, we've got time for a couple more questions here. So does the Jupiter-Saturn conjuncture this year play a role in the solar cycle and in turn weather on Earth?
There is nothing that I have ever seen that would make that statement of Jupiter Saturn alignment and its impacts on the planet Earth impact our weather. I am someone who will never say never, and I will not say that you're crazy in thinking that. That is not my way of doing science like a lot of other people do. But I'm just saying Daryl Ritchison has never seen any evidence to support that. Doesn't make it true or untrue. And I'll leave it at that.
Good. Thank you, Daryl. 2 more here. So any comment about the impact of deforestation on weather patterns?
Deforestation on weather patterns was the question. You have to remember, deforestation is a warming process. But also the deforestation is almost always replanted. And the other thing is you have to remember, we deforested the United States 100 years ago, much more dramatically than anything we've done recently. And so in turn, I think in a microclimatic area, there would be some impacts. It'd be kind of hard not to maybe argue that point, but because most of the northern plains, most of where we grow stuff, there just aren't any really trees to deforest. And in turn, I don't think it's a regional problem. So again, Daryl Ritchison's opinion only, that I would say no, not for our particular area as a whole.
The last question here for you, Daryl.
Last question. And my next speakers are here.
Does the transition to the 20th century average precipitation correlate to earlier frosts in the fall?
Only in the sense of, this past year is an example of things that are rules that don't always work out. So I've always told people, if you heard my previous talks, and every August I get asked the same question. And it's a good question. And I understand why people are asking me, are we going to have an early frost this year, Daryl? And I always tell them that when we have a dry August, historically, we tend to have an earlier than average frost. Not every year, but more often than not. It's a usable term. We had a dry August this past year. And in turn, we had an early frost. I remember in late August, people were going, hey, are we going to have a frost, the first week of September? Because there's a lot of rumors out there on the internet at that point suggesting that. And I said, no, but we might on the second. We'll see how that ends up going, which in turn we ended up doing that. So I would still key in is when you're drier than average, the soils radiate. Look at these days lately. And granted, it's a whole different scenario. It's winter time right now, but we're hitting 60 in the afternoons lately in southwestern North Dakota, and then their lows are down around 20. A lot of that is just very dry atmosphere. So soils play a huge impact on localized temperatures from spot to spot. Now, the great joys about NDAWN is as we add more and more stations, I learn more and more about North Dakota because we've never had a temperature sensor there. And so I'm learning about a lot of different microclimatic areas in the state. And I'm also learning, farmers will go, well, Daryl, we could really use a station here because this area is different than the areas nearby. And part of me goes, I don't know if I necessarily believe that. I put a station there, and of course the farmer is right, because they're always right, because they know that stuff very, very well. So I'm just saying that soils, though, is one of those many factors that plays an important role sometimes, and if a frost or a freeze and different elements that are out there, even no-till to traditional tillage makes an impact on the temperature a little bit, because 1 or 2 degrees, if it's 80 or 81, it doesn't matter. If it's 32 or 33, it does matter. And so that's why there's those subtle little points on there going forward that, yeah, if we go a little bit drier, we might do it a little bit earlier, but I think the overall average might just be, again, going back to the old frost average of 3 or 4 days earlier that we had, say, 20, 25 years ago. But anyway, my time is up. If you have any more questions, my contact information is on the screen. Any questions about NDAWN, any questions that we didn't cover today, please ask me. I'm already pre-scheduled for this conference next year, and I am greatly looking forward to be able to see all of you in person again in 2021. So again, thank you very much, everyone.